Why? Look at these 6 factors. First, uneven heating of the Earth's surface due to the axial tilt. So it's going to be warmer at the equator, and as you radiate out, it's going to have decreasing temperature. Number 2, latitude. And number 3, global patterns of air circulation. These are the questions that you should consider while talking about air circulation. Here you can see 3 types of cells: the Hadley cells, Ferrel cells, and polar cells. If we take a closer look at the Hadley cells, we can see that there's going to be rising air, thus causing a moist tropical climate at the equator. There's also going to be descending dry air, which is going to absorb the moisture, which is why we have deserts at 30 degrees north and 30 degrees south. Let's not forget about the Coriolis effect. Instead of just moving north and south, the winds also move west and east. Quick comment, the names here, if we look at this, for example, westerlies, it's not moving west, but it actually comes from the west. So all these names are referring to the origin of the direction of the wind, not where they're going to, but where they're coming from.
Most ocean biodiversity is found in shallow water near continents, but 91% of marine species still await description. There are hotspots of coastal taxa in the western Pacific, and hotspots of oceanic taxa in temperate mid-latitude areas. There are 4 main drivers of species diversity, distribution, and abundance. These 4 are temperature, ocean circulation and major surface currents, nutrients in primary production, and depth. Sea surface temperature is the greatest driving factor of biodiversity. Most biodiversity is found in the shallow, warmer water near continents.
The second driver of ocean biodiversity is ocean circulation and the currents that create this. The first process of ocean circulation that we should know is the Coriolis effect, which effectively determines the direction in which currents are going. The Coriolis effect is produced by the rotating motion of the Earth and how that creates the apparent movement of currents in a slightly twisted direction. Surface currents, which are produced by the Coriolis effect, contribute to upwelling and downwelling, which brings us to our next driver of oceanic biodiversity, which is nutrients and primary production. Upwelling is the process by which water that is deep in the ocean is moved up to the surface, bringing nutrients and giving it to phytoplankton and zooplankton, which are the primary producers. In areas in which there is upwelling, Since there's lots of nutrients, there's lots of species biodiversity. Likewise, downwelling occurs when surface currents bring surface water deep into the ocean, bringing nutrients to the ocean floor, and this could be seen in certain situations known as marine snow.
The final physical force influencing oceanic biodiversity is depth. As depth increases, the ocean is divided into two parts, the photic zone and the aphotic zone. Organisms living in the photic zone can take advantage of the sun as an energy source for photosynthesis. The aphotic zone, below about 200 meters, begins where no more light is present. Water temperatures also vary at different depths as well as at different times of the year in temperate areas. The warmth of the water decreases with depth. Thermoclines are distinct areas where the water temperature changes very rapidly with depth. Pressure increases rapidly with depth also at about 1 atm with every 10 meters. Haloclines occur as a result of a distinct salinity gradient as shown in the image above. Pycnoclines result from a difference in both salinity and temperature. The ocean is divided into several zones, both laterally and horizontally. The neritic zone includes the shallow ocean along the coast from about 0 to 200 meters. A large variety of organisms inhabit this area because of the nutrient-rich waters. The littoral zone, 0 to 100 meters, is part of the neritic zone. Because of wave action, organisms here, such as those living in the rocky intertidal zone, develop a wide variety of adaptations such as anchoring. The pelagic zone is concentrated away from the shorelines and includes both photic and aphotic zones. Energy sources are photosynthesis in the photic zone and fallen organic matter and chemosynthesis in the aphotic zone.
Hi, my name is Michael Buren. First, a brief overview of where all the water on Earth is found. 96.5% is ocean, 0.9% is saline water, and only 2.5% of the Earth's water is found in fresh water. Limnology is the study of science dealing with the physical, chemical, biological, and meteorological study of the inland waters. You can't study freshwater dynamics without knowing your limnology. Also important to note is there are two freshwater systems, the Lotic system, which is flowing rivers and streams, and the Lentic system, which is still lakes, inland freshwater seas. Beginning with the Lotic system, we look into rivers and streams of the world. Here we see an image of the major features of rivers. It is important to note the riparian zone, which is the interface between the land and the river, which is made up of hydrophilic vegetation. In this image, you can also see the meandering of the river. Meandering here is the curvature and the bending of the river due to deposition and erosion of sediment. Oxbow lakes are an important feature which form due to meandering. Oxbow Lake is a U-shaped body of water that forms when a wide meander from a main stream of stem is cut off, creating a freestanding body of water. Resistance time is an important measurement to be aware of as well in the freshwater system. It is used to gauge the input relative to the lake volume and determine how much sediment can occur.
Hey everybody, I'm Steven Carpenito, and I'm here to tell you all about freshwater sources and features. Important freshwater sources are aquifers and spring inputs, and these sources yield both persistent and ephemeral freshwater features, ephemeral here meaning seasonal or temporary. Examples of persistent freshwater features can be natural, such as Great Lakes, fjord lakes, Rift Valley lakes, and these mainly get their input from precipitation, and artificial, such as dams, quarries, depressions, and reservoirs, which can get their input through controlled flow, precipitation, or both. Ephemeral freshwater features are also quite diverse and can be found in many different examples, such as mountain lakes due to snowmelt, glacial lakes due to glaciated snowmelt, oxbow lakes, which we have previously described as entrapped river water, aeolic lakes due to wind depressions and condensation in the desert and only last for a few days, epitself lakes due to the sea ice meltwater, subterranean lakes due to aquifer seeps, vley lakes due to seasonal water table shifts, volcanic crater lakes due to vent seeps, and vernal pools due to precipitation which form annually and then dry up by the end of summer. Vernal pools are critical habitats for many different types of amphibians due to the lack of natural predators such as fish that would eat the larvae. As such, vernal pools have been the focal points for major conservation efforts recently. As you can see, freshwater features, both persistent and ephemeral, are both incredibly diverse in their formation.
Hello, my name is Amanda Carlos, and I'm going to tell you everything you need to know about lakes. Freshwater columns are made up of 3 zones. The first surface zone is called the littoral zone, which is located on the edge of lakes and rivers and is defined by narrow and broad fringing wetlands. Under that is the limnetic zone, which is well-lit, open surface water away from the shore. These 2 zones make up what we call the photic zone, an area with enough light that allows primary producers to perform photosynthesis. Finally, we have what is called the profundal zone, which is a cold, stable zone with not enough light for photosynthesis to occur. Turnover is a seasonal dependent process which occurs in lakes in which the warm water becomes more dense and sinks to the bottom, and the cold deep water rises to the top. Holomictic lakes have frequent turnover, and meromictic lakes have no turnover. Lakes can be categorized as oligotrophic or eutrophic. Oligotrophic lakes lack nutrients and are very clear because of the lack of primary producers, while eutrophic lakes have high turbidity due to the large amount of photosynthetic activity. Thanks so much for watching our video!